Hello everyone, welcome to the session number 6 of double integration. So in this session you will learn the prerequisite of polar coordinates, means what are the polar coordinates and which polar curves we require to solve the type 4 examples of double integration. Not only that, I will show you how to take the limits of double integration in polar coordinates. So that is the main aim of this session. So before this session, whatever the examples that were done in a Cartesian coordinate system, if you see if you see the graphs that you used for plotting the graphs of Cartesian curves, so generally we have this x-axis. This is the x-axis, and say this one is a y-axis. Now this coordinate system x-y axis is in uh, divided by some lines which are parallel to y-axis like this, and some more lines which are parallel to x-axis also like this. This type of the graph papers you have where these two lines are again divided with small lines of say that type of the graph papers you use for plotting the Cartesian coordinates or Cartesian curves. So say we have a Cartesian point, say x comma y. The Cartesian coordinate x comma y, say we are given, say I will consider, say 3 comma 2, 3 comma 2. Now see how do we reach to this point 3 comma 2 in Cartesian. In Cartesian, this is our origin, say 0 comma 0, 0 0 is the origin. So what we have to do it, we have to move 3 unit along x-axis, so this way. Then we move 2 units on y-axis, and we get a point 3 comma 2. Not only that, yes, we can first move on y-axis also 2 unit, and then along x 3 unit, then also we can reach to the same point. So what happens, we can move to the point, any point x comma y in the Cartesian coordinate, we by moving on the boundary of a rectangle. So this Cartesian coordinate system is also known as a rectangular coordinate system. This is a rectangular coordinate system. But we have to learn now the polar coordinates. The polar coordinates are given in terms of r comma theta. So it is again a pair. So coordinates of polar are given as r comma theta. Okay. Now in this case, to move this on r and theta, so what we have to do it, first we have to draw the line of theta. We have to draw the line for theta, and we have to plot the magnitude r on that. So before we go to that, I will just show you one small relation between xy and r theta. So let me first focus on that. So we have, say, p of xy, any point in the plane. So this point have the Cartesian coordinate x comma y, as well as this point, if we transform to the polar, so the coordinates will become r comma theta. So point remains same. The position of the point remains same. For this point only, the Cartesian coordinates are xy, and its equivalent polar coordinates are r theta. Already we learned here how to go to the Cartesian. We move x distance on x-axis. Then we move y distance on parallel to y-axis there. Just a minute. So this one is y. So obviously this is a perpendicular. So that about x and y in the diagram. Now, if you see here, the next thing that we have is if we join this origin with the point P, so the length, whatever this OP is there, that is known as R. R is the length of that point P through origin, and theta is an angle. Theta is an angle made by that OP with a x-axis. So right now all the four uh, variables are plotted in the diagram. XY are the Cartesian coordinate, while r theta are the polar. From the diagram itself, it is very clear. In this right angle triangle, x is the adjacent side of a theta. Hence, cos theta, that is cos theta is x upon r. So first relation we get is x equal to r cos theta. X is r cos theta, and the front side is y, that is r sin theta. So these are the values of x and y in terms of r and theta. So these relations are important in type 4 later on. So when we transfer the double integral from Cartesian to polar there. So these are the important relations. Yes, reverse relations are also there. If you see the r by Pythagoras theorem, the value of r is a root of x square plus y square. Value of r is a magnitude, that is the root of x square plus y square. Remember, the magnitude of the point is always positive. We'll never take a negative magnitude. Whenever some negative magnitude comes, we say that is an imaginary magnitude there. Okay, so we cannot plot that in negative magnitudes. So just take r as a plus root of x square plus y square. So this square root have only positive sign, that is r. And what about theta? Theta is a tan inverse y by x. Theta is a tan inverse y by x. So that about some relation between Cartesian and polar coordinates. So this is the introduction for mainly, I would say, the polar coordinates. So what are the polar coordinates? Polar coordinates are like this, r comma theta, and that are the relations there. Now uh, here already I told you how the Cartesian plane looks like, or Cartesian graph paper is given like this. Let I show you the graph paper of a polar curves. So the graph paper of the polar curves is given like this. This is a graph paper actually for to draw the polar curves. Okay, I will just show you one of the graph for getting an idea. Now the polar curves, polar equations are like this. Say r is equal to r is equal to 4. A very simple curve I taken. When I want to plot this r equal to 4, remember r is independent of theta. Okay, so what we have in the polar graph paper, we are given. So just this is another important thing you should remember. The first line, that is theta equal to 0 degree. This theta equal to 0 is known as the initial line. This line is the initial line. It is not considered like x-axis. Okay, you can say x-axis, but you should know the equation of x-axis in a polar, that is theta equal to 0. Theta is a 0 is equation of positive x-axis in the polar graph, and the equation of y-axis in the polar, we say equation of y-axis in the polar is theta equal to pi by 2. That is line perpendicular to initial line. This line is known as line perpendicular to initial line. Now how to plot the points in the polar? See, for theta equal to 0, r is a constant. Actually r is a constant for every theta. Take any theta, take any line of theta. So this is 1 unit, 2 unit, 3 unit, 4 units. So this is the first point. 1 2 3 4. So this is a r equal to 4 for 45 degree, and so on. So if we join all these points for all the thetas, r is a 4, we get r equal to 4 circle. So r equal to 4 is a circle. So what is r? R is a root of x square plus y square. R is root of x square plus y square is a 4. So x square, squaring both sides, x square plus y square equal to 16, and you will observe x square plus y square is a circle with the center 0 0, radius 4. So the center is a 0 0 here, and that radius is a 4 unit. So this is the 4 0. So this way we get the polar curves. We can draw the polar curves with on this graph paper easily, but nowhere you have to take this graph paper. Nowhere the graph paper will be provided. You should draw the rough sketch of the given equation directly. So we'll come to these prerequisite curves one by one, and we'll see how to get their limits also. So we'll move to the prerequisite curves here. The for simplicity, I assumed here let a is equal to 1. Okay, let assume a is 1 whenever we draw any curve. So the first curve that we have is r equal to a. R equal to a. Now to draw this curve, you will observe for this curve you will observe take any theta, r is equal to a only. For example you will observe say theta equal to 0. What is theta equal to 0? R equal to a. So this is a line theta equal to 0. Okay, this is a theta equal to 0. On theta equal to 0, r is a, so this coordinate will be a comma 0. This is the important thing. Now you may think, yes, this is like in xy plane only. In xy, yes, the coordinates are a0 only, but here the first a is r and second is a theta. So a comma 0 is r comma theta. Now you should guess what will be the coordinate of this point. Okay, the coordinate of this point in a polar will be, see, r is a only, the length is a, because for theta equal to pi by 2 and a comma pi by 2, a comma pi by 2 will be the coordinate of this point. This point will r is equal to a only and a comma pi, and the last this point r is equal to a 3 pi by 2. So these are the coordinates of the points in the polar. Okay, so you don't think like it is a minus a0. Minus a0 is a correct provided you are in xy plane. If you are in xy plane, it is minus a0 because minus a is x and y is a 0. But in polar, this length is a only. The length is a on theta equal to pi, on the line theta equal to pi. So what we do generally is, suppose we have to evaluate some double integral over this circle. So what we do it, we generally take a strip, the strip along the radial direction. This is like a radial direction. Now, what is the position of strip? Just see, this is just like a clock. Okay, this is like a analogous clock, and this is one of the hand of the clock, say minute hand or hour hand. So you have to see where the lower end touches. Lower end touches to r equal to 0 because the region starts at origin only. So the lower limit of r is a 0, while the upper end touches to the curve r equal to a. So what will be the limits here? R equal to a, r equal to a, sorry, 0 to a, my mistake. Lower limit is 0, upper limit is a, r equal to 0 to a. What about theta? Now see, this inner end is always fixed. The inner end of the radial strip is always fixed, and you have to rotate. You have to rotate to cover the entire region. So the region starts at theta equal to 0 to, you can complete rotation, you can take complete rotation. So theta is 0 to 2 pi. So that about the limits of r and theta for r equal to a. So whenever the circle is there, r equal to a, always limits are 0 to a, theta 0 to 2 pi. That also you can remember. Directly you should able to draw this graph, and these coordinates, no need to write it. A comma pi by 2, a comma pi. This is just for your understanding I am showing you. They not require at all. Okay, so only you should know the limits of r and theta, that only we require there. So come to the second curve then. Three circles are there. So second is r equal to 2a cos theta. R equal to 2a cos theta can be simplified in Cartesian as x square plus y square equal to 2x also. And remember, r equal to 2a cos theta, r equal to 2a cos theta is a circle on with a diameter 2a, diameter 2a on x-axis. Okay, so 2a will be a diameter and that will be on x-axis. Now, what will be the coordinates you will observe? So this is a theta equal to 0. If you put theta 0 here, if theta is 0, cos 0 is 1, r is 2a. So coordinate of this point are 2a comma 0. This is a 2a comma 0 because theta 0, r is 2a. Now come to this point. Now, whenever you have the point at origin, you want to find coordinates of origin. So what should be the value of r then? At origin, the r will be 0, r will be 0. Just replace r by 0. If r is a 0, cos theta is 0. When cos theta is 0, cos 90 is a 0. So coordinates of this point will be 0 comma pi by 2. I will write it here, 0 comma pi by 2. So that will be the coordinates. That will be the coordinates of origin. So origin will not have coordinate now 0, 0. 0, 0 is in xy plane. X is 0, y is 0. But in polar coordinate, the coordinates of this point is r is a 0 when theta is pi by 2. Now if you replace any value in this equation from pi by 2 to 3 pi by 2, I will tell you pi by 2 to 3 pi by 2. What happens? R comes negative. For example, say theta is a pi. When theta is a pi, what happens? Cos pi is a minus 1, r is a minus 2a. Whenever r is a negative, don't plot that values. That part is known as a region of absence. By observation also, it is clear the circle exists. This part is in first quadrant. This circle exists in fourth quadrant. So in this case, this second quadrant and third quadrant is known as a region of absence. There is no curve. There is no curve in second and fourth quadrant. Okay, so what is the why we require all this information? Because this decides the limits for double integral. Now whenever we take the strip, whenever we take this radial strip, the strip is along a radial direction, the strip is fixed here. or fix at origin, and you have to see the lower end touches to r equal to 0, upper end touches to this r equal to 2a cos theta, whatever the equation of the curve only. So this is the upper end will vary on that circle r equal to 2a cos theta. So limit of r is very simple here, 0 to 2a cos theta, 0 to 2a cos theta. But the outer limit of theta, outer limits of theta, you will observe theta starts, the curve starts at theta equal to 0, and curve, this half of the curve ends at pi by 2. So will be theta will be 0 to pi by 2 only right now for upper semicircle. Now from pi by 2 to 3 pi by 2 there is no curve, so you cannot say there is a region. So after that you can say 3 pi by 2 to 2 pi, or you can say whatever the limits, whatever the curve we get, whatever the region we get in the first quadrant, exactly same region is in the fourth. So you can say just you double integrate on first quadrant, double integrate on first quadrant, and you take 2 times, because exactly same, whatever this area is there, whatever this area is there, exactly same area is on this side. So you can say 2 times, 2 times, 2 times of 2 times of 0 to pi by 2. That's one. So this is the way you can get, why 2 times? Because it is a symmetry we used. Region in the first quadrant, means 0 to pi by 2 is same as in the fourth quadrant. Okay. So this is the limit. These are the limits of r and theta in the double integral for r and theta. Remember, limit of theta is always a constant, because theta is just angle, and that angle is always a constant, and that will be always outer limit. Outer limit. Okay. So that about second curve here. Now we'll move to the third curve here. Next, third curve. Third curve is r equal to 2a sine theta. This is again a circle, but in this case, 2a sine theta is a circle whose diameter is on y-axis. The diameter of the circle will be on y-axis here. And now, what will happen if you want to see this coordinate? This coordinate. So see, this point is at origin. To get origin, r is a 0. Replace r by 0. If r is a 0, sine theta is 0. What is sine 0? Sine 0 is 0. So the coordinate of origins are 0, 0. While the coordinate of this point is on theta equal to pi by 2. So replace theta as pi by 2. Sine pi by 2 is 1. Sine pi by 2 is 1. So r is a 2a. R is a 2a and theta is pi by 2. So 2a comma pi by 2. So 2a comma pi by 2 is the coordinate of this point. Lastly, we want a strip. We take a strip generally along radial direction. So this is the position of a strip, and this strip we are going to drag it where the inner end is fixed here to r equal to 0. So r will again vary from 0 to the equation of curve, that is a 2a sine theta only. But what about theta? Theta will vary from 0. You will observe it is 0 to pi by 2 and 2 times again. 2 times 0 to pi by 2, or directly 0 to pi, because in this case this third and fourth quadrant is a region of absence. Region of absence is third and fourth quadrant. So you can directly take 0 to pi or 0 to pi by 2, but again the same symmetry we use, and 2 times of 0 to pi by 2. You will observe whatever the region you get in, whatever the region you get in this 0 to pi by 2, exactly same region you get here, that way. Okay, so that's a third. So there are 3 circles you require, either r equal to a, r equal to 2a cos theta, r equal to 2a sin theta. R equal to a, circle with center 0, 0, radius a. 2a cos theta, 2a is a diameter on x-axis. 2a sin theta, diameter is a 2a on y-axis. So that about third curve. Okay, that about the third curve. And now let me see the fourth one. Fourth one is a lemniscate. Okay, lemniscate. So this curve, it looks like infinity, just symbol of infinity. Okay, I will just erase the upper part there so that you get. So this is the curve that we have, lemniscate. Lemniscate looks like infinity symbol. This is infinity symbol. Okay. So equation is r square equal to a square cos 2 theta. So whenever this equation will be given to you, r equal to a square cos 2 theta, you should able to draw this curve. You should able to draw this curve. Now the interesting part, come to the coordinates here. Come to the coordinates. So replace theta by 0, because this point is on initial line theta equal to 0. So replace theta 0, cos 0 is 1. So r square is a square, r is a plus or minus a. So this point will be a comma 0, a comma 0. This coordinate is actually a comma pi. See, r is never negative. Don't confuse. Minus a0 is okay, but minus a0 is a point in xy plane. A comma pi. So whenever the point is on negative x-axis, theta is pi there. So this is r comma a. Everywhere we are writing r comma a. Now come to the origin. The coordinates of origin. Don't say 0 0. 0 0 are coordinates in xy plane. Here we have to find out the value of theta where r is a 0. So replace r by 0. So cos 2 theta is 0. Cos 2 theta 0 means 2 theta is pi by 2. So theta is a pi by 4. So the coordinate of this point is r is a 0 comma pi by 4. 0 comma pi by 4. So that is the coordinate of this point. Now again we are going to use symmetry. So whatever the region we get in the first quadrant, okay, same region is in the remaining quadrants. So the limits of this when you take a radial strip like this, the limit of r, r will vary from 0 to the equation of curve, that is a into root of cos 2 theta. That will be the limit of r. And what about theta? Theta will vary from 0 to, don't say pi by 2, because this point we get for pi by 4, 0 to pi by 4 only. And here we take 4 times of this, 4 times of 0 to pi by 4. What happens if you take wrong limit, say 0 to pi by 2? Your answer will be a wrong. The reason is there are some imaginary curves for which you are calculating the double integral, because already I told when r is a negative, that curve is not plotted. So from pi by 4, theta equal to pi by 4 to 3 pi by 4, there is no curve. Like in previous, here there is no curve, here there is no curve. Why there is no curve? Because r is a negative. And if you use wrong limit, say 0 to pi, 0 to 2 pi, like that, so your answers will come wrong there. So that's a lemniscate fourth curve. That is a fourth set of the curve here, and last set of the curves that we have a cardioid now. So the name is given cardioid because these are heart-shaped curve. Okay, so there are total 4 cardioid known as a right-hand cardioid. R equal to a 1 plus cos theta. 1 plus cos theta is on right-hand side this way. Then r equal to a 1 minus cos theta is a left-hand cardioid. So the cardioid is on the left side there. Then we have r equal to a 1 plus sine theta is upper cardioid. So cardioid is on upper, and last r equal to a 1 minus sine theta is a lower cardioid. So cardioids are again a very important. So number of questions are on the cardioid. Let me just focus on first cardioid here. For this cardioid, for the first cardioid here, see the first point. This is on this line theta equal to 0. If you put theta 0, cos 0 is 1. So r is equal to a times 1 plus 1. So it is a 2a. It is a 2a comma 0, because theta 0, r is 2a. Come to the origin. When this r is becoming 0, if r is a 0, 1 plus cos theta is 0. That means cos theta is minus 1. When cos theta is minus 1, when theta is a pi. So the coordinates of origin are r is a 0, then theta is pi, this way. R is a 0, theta is pi. So that about the origin coordinates. Again, we can use the symmetry here. Just focus on the upper only. This part we can evaluate the double integral, and the strip we take a radial like this. Okay, radial like this. So r will vary. R will vary from 0 to a times 1 plus cos theta. A times 1 plus cos theta is equation of cardioid, while theta will vary from 0 to, see, first point we get for theta equal to 0, and this point origin we get for pi, 0 to pi. But because of symmetry, we can take two times of this. That's the limit of a right hand cardioid. So similar things are there for others also. So for others, if you draw the strip position like this in the region, so this point will get this coordinate of this point we get as coordinate of these points are when say cos 0 is 1, cos 0 is 1, 1 minus 1 is a 0. So r is a 0, theta is 0. So origin is 0 0 now, like that. but this point we get 2a comma pi. Okay, so in this case, yes, r will vary from 0 to this curve only to a times 1 minus cos theta, but theta will be 2 times 0 to pi, 2 times 2 times theta will vary from 0 to pi to cover the entire cardioid. I'm saying entire cardioid. So 0 to pi, whatever we get in 0 to pi, same thing we'll get from pi to 2 pi. So because of 2 times 0 to pi, that will be the limits of theta. R obviously inner end touches to 0, upper end a 1 minus cos theta. Come to the next here. So coordinate of this point. Now when r is a 0, 1 plus sine theta is 0. So sine theta is minus 1. Sine theta is a minus 1. Yes, any guess? When sine theta is a minus 1, it is a 3 pi by 2. So 0 comma 3 pi by 2. 0 comma 3 pi by 2 is the coordinates of origin. While the coordinates of this upper side is r is equal to 2a when theta is pi by 2. And take a strip here. The position of strip is along the radial side. It is just like a hand of the clock. We're rotating from now. See, r will vary from 0 to the equation of curve only. But what about theta? Theta will vary from see, it will not 0 to pi by 2 or that way. If we have to cover at least this right side here, this side, to cover right side, the theta should vary from say 3 pi by 2 to pi by 2, or this is pi by 2 to 3 pi by 2. Okay, you can take any one of that. So 3 pi by 2 to pi by 2 is also okay. I hope you are getting. So first point r equal to 0 we get for 3 pi by 2, and 2a comma pi by 2 we get for pi by 2. So you can take 3 pi by 2 to pi by 2, or this side pi by 2 pi by 2. So we are moving this way. So yes, so choice is your, yes, both way. So I will write theta is a pi by 2. I'm taking this side limit. Okay, I'm taking mainly this side limit. Just I will highlight this one, this side. So for this side, theta will be pi by 2 to 3 pi by 2, and it is a 2 times again, that way. So this is the way generally we take a limit. Last curve, actually the last curve, I think there is no example on that, but still, if you see here, the origin have the limits 0 comma pi by 2, because sine pi by 2 is 1, 0 pi by 2, and these limits are say 2a comma 3 pi by 2. This so the limit goes like this only. We are thinking on this side only. So pi by 2 to 3 pi by 2, 2 times, that way. So that about your prerequisite curves. So all the prerequisite curves that we completed now. Which are the curves? 3 circles, 1 lemniscate, 4 cardioid. So total 8 curves are only there. Only 8 curves. You should remember that. So any one of that curve we require while solving the example of polar coordinates. Now whatever I told, the position of strip and all that thing that are shown here. Suppose the this region is our region of integration, and our region lies between theta equal to alpha and theta equal to beta. So the outer limits of double integral are alpha to beta. But the region starts at r equal to 0 and ends at r equal to f theta, means upper end varies on this curve, and the equation of curve is r equal to f theta. So the limits are 0 to f of theta. That are the limits of r and outer of theta. So this is the case 1. Case 2 will be like this, where the region is not at origin. So region is away from origin. See, when you draw this strip, the strips enter in the region at r equal to f1 theta, and strip upper curve have the equation f2 theta. So r will vary from f1 to f2, while theta is always a constant, that is alpha to beta. So that about the strip position. So always just correlate the strip to the hand of the clock and rotate it from 0 to 2 pi and check where the region starts and where it ends. So wherever the region starts, start with that theta, and if the region completed, stop it there. Don't drag extra. Not necessary always you have to drag it completely from 0 to 2 pi. That we already seen in the previous prerequisite curves. Okay, so that about your prerequisite. So next session we'll see the examples on type 4 where we see solve the examples in a polar coordinate. Thank you. Good day. Bye.